Hi everyone. In this video we're just going to do a little bit of practice in using left and right hand sums to approximate the value of integrals. So this is basically exactly what we were doing in 1.3. We've just introduced the definite integral notation. So when I ask you to approximate the integral from 0 to 4, you need to know what that actually means in terms of areas. And this is a great one for you to pause and work ahead. There's nothing terribly tricky going on here, but there's some kind of interesting things that happen as we increase the number of rectangles. So I'll walk through, but you should have paused and already checked some of these out and see if you can figure out what's going on that I am interested in. Okay, so we have this function. We are going to try to approximate the integral from 0 to 4, which is the area trapped under the curve from 0 to 4. There's no negative y values, so we don't have that weirdness. We do have a discontinuity, but the truth is that that doesn't really matter all that much. We are drawing area trapped directly below the curve, so we're just going to, we can look at it in two chunks if you want. We're going to be getting those two. The fact that there's an open circle at the top doesn't really make much difference. The area trapped directly under that open circle, well, there isn't area basically. It's just a straight line trapped underneath, so we're not gaining or losing area based on where that open circle is. In fact, even if both were open, we could still talk about area. Losing that one single point doesn't mess with your area. Interestingly, it works out kind of nicely. Okay. So that's our area. We first want to use L sub 2 and R sub 2. So if we use L sub 2, two rectangles, they're each going to have to be 2 wide. We're going to use left-hand corners to determine the height of each rectangle. So there's rectangle number 1. And very boringly, there's rectangle number 2. They're both the exact same height. So we have a base of 2, a height of 1. I guess we could have just gone base of 4, but that's okay. So the first rectangle is 2 by 1. The second rectangle is 2 by 1. So L sub 2 is 4. Okay. Green. For R sub 2, the first rectangle, we're going to use the right-hand side of our interval. And again, there is actually an open circle there, but that doesn't really make that big of a deal. We can just still say, okay, this would be what our rectangle would look like given a picture. Oh wait, I'm being completely silly. What am I talking about? If we're using, I was trying to make total stuff up. Hopefully you caught that I was being ridiculous. If we're using the right hand, this is what happens when I scribble all over it. We're going to hit that point. So the height of our rectangle is still going to be determined by that point. So that's rectangle number 1 is actually identical. Rectangle number 2, its height is actually 0 because the right-hand side we're hitting the axis. So R sub 2 gives us 2. These both seem like fairly awful approximations. I would say they're both underestimates. R sub 2 is an even bigger underestimate, but L sub 2 was also underestimating. We were missing all this jazz up here. So not great estimates, but estimates nonetheless. Okay, so let's go ahead and see what happens when we jump up to R sub 4. So L sub 4, R sub 4. Let's go ahead and do L first. Let's see if I can quit. Here, we'll make it that nice dark one. Okay, so now our rectangles are each going to be 1 unit wide. We're using left-hand corners again. So the first one is also going to be 1 tall. The second one is going to be, looks like 2.5 tall. The third one's going to hit that discontinuity, be 1 tall. And then the fourth one is going to be just a little taller than that. So I'm going to say this is 1 by 1, which has area 1. Number 2 is 1 by 2.5, 2.6 maybe. I think it's about 2.5 in my picture. Number 2 is 1 by 1, and then number 3, what if this is 1.5? Let's say that's 1.2 by 1. So 2, 3, 4, 5.7. And these should really be approximate. Okay, when we go to do right, same endpoints, but now the first one is going to be 2.5 tall. So there's number 1. The second one is going to drop down and be 1 tall. Again, ignore that open circle that I was trying to pretend like it was helping me before. It absolutely isn't. Kind of the point of this problem if I was thinking carefully. Okay, and then the third one is 1.2, and then the fourth one is 0. So once again, with the right-hand endpoints, our last rectangle is really flat, which means we're missing this whole chunk right here. And our second rectangle is also missing a pretty good chunk. In fact, our first rectangle, we're missing lots of things, so still definitely getting an underestimate here. Okay, so what do we have? We have a 2.5, a 1, a 1.2, and a 0. So 2, 3, 4.7. Okay, so still both underestimates, I would say. We're missing chunks no matter which way we do that. All right, so let's step it up again. Let's say we want to find, okay, so I'm just going with L's now. L sub 5 and L sub 6. We haven't done an even yet. So for L sub 5, that's kind of awkward. If we take 4 units and we divide it by 5, that means each one is going to be 0.8. So we're going to go 0.8, and then we're going to go 1.6, and then we're going to go 2.4, and then we're going to go 3.2, and then we're going to go 4. Okay, so we're estimating from this picture, but this should give us an idea. So the first one is my same old 1 unit tall. Oh, but I better be careful. That's 1 unit tall. It is not 1 unit wide anymore. The second one, let's say, we'll just take it. That looks pretty spot on. It's about 2 tall. The third one, where am I supposed to be here? 0.6, 1.6. Okay, so we run up. We're a little to the right of center. Let me say that goes about there. That one's kind of ugly. Pretend it's nice. Okay, the fourth rectangle, we're going from 2.4, so it's a little left of the middle. And that looks like it's about 1.1 tall. And then the last one, we hit just about at the top of that. Okay, so I still think we're getting an underestimate, but it's looking kind of nice. We actually caught a whole bunch of this chunk that we've been missing completely. We got a whole lot closer to hitting the top. So this first one is, here, let me erase my scribblings out here. It's 1 tall and it's 0.8 wide, so about 0.8 total. Ooh, I already think I'm going to get sad and want my calculator. Maybe, maybe not. Hold on, let me get it ready. Okay, the second one is about 0.8 wide and it looks like about 2 tall, so that would be area of 1.6. The third one, this is the one I feel like I want a calculator for, 0.8 wide. Again, I'll try to be nice to you on tests. You should be able to do some arithmetic by hand if needed. Okay, so it's about 0.8 wide and what, like 3.7 tall, which gives me about 2.96. I'm just going to round up to 3, I'm estimating anyways. You don't always want to just chop it off to make it convenient, but I definitely think it's fair to say close enough at 3. The third one is 0.8 by 1 again. And then the fourth one is 0.8 by, oh, I don't know what, 1.2? 0.8 by 1.2 is about 0.96. So we could say that's roughly 1. Okay, so what do I have? 0.8, 0.8. I have 1.6 plus 1.6 is 3.2, plus 3 is 6.2, plus 1 is 7.2. This again should be approximate. If we do the same thing, only we want 6 rectangles. Okay, I'm going to go ahead and erase. I don't think I can keep track with that much scribbling going on. Now we want each rectangle to be, what are we doing, 4 over 6, which is 2/3. So we're going to go to 2/3, and then we're going to go to 4/3, and then we're going to go to 2. And then we're going to go to 2 2/3, and then we're going to go to 3 1/3, and we're going to go to 4. Okay, so we're going to run up here, and then up here, and we'll say that one hits pretty close to right on. And what are we doing? We're doing left-hand sums. Okay, so this one, here, left-hand sum. The first one is going to be 2/3 by 1. 2/3, if you can read that. The second one is going to be whatever that is. Let's say it's 2/3 by 1 2/3, which is what? 5/3? 2/3 times 5/3 is 10/9. And then we'll say this one is 2/3 times 3, which gives us area 2. The next one is 2/3 by 1, 3. Let's say that's about 2/3 by 4/3, by 1 1/3. Again, that's rough, but makes the arithmetic a little easier, which is 8/9, a little less than 1. And then the last one actually looks like it'll be about the same size. Looks like it hits at the same y value, so another one that's 8/9. Okay, so what do we have here? We have, we're going to write out what we have. 2/3 times 2, and then we have a 10/9. So that's the first, the fourth, and the second. That's supposed to be a 10/9. And then we have a 2, and then we have 8/9 times 2. Okay, so we're getting 4/3 plus 10/9 plus 2 plus 16/9. Okay, so 4/3 is 12/9, and 2 is 18/9. So, what do I see? I see 12, 22, okay, 12, 22, 32, 40, 56 over 9. Is 3 going to 56? No, not nicely. I think we're good on that. And again, there's some estimation here, so it doesn't have to be spot on. Ooh, I kind of think I want a decimal for that. 0.565656, is that true? And then check if I remember all my good fraction division sheets. 56 over 9. Oh, no, I definitely lied. 6.555, so 6.56. Okay. So, let's see, picture-wise, I think both of those are doing a little bit better. I would say it's hard to see, but I would actually say that I think the red one caught a little bit more of what we've been missing, maybe. So D actually gets into that a little bit more. Part D, oops, gives you some values. So if we know that L sub 9 is 1.73, L sub 10 is 6.56, L sub 11 is 7.149, and then we're finally given what the exact area is. So the exact area we've been trying to estimate all along is about 7. So you can see that L sub 2, R sub 2 sucked, L sub 4, R sub 4 a little bit better, L sub 5, L sub 6 definitely starting to get closer. And I think that I didn't lie to you when I said that L sub 5 was doing a little bit better job than L sub 6. And we see the same thing happening here, is that L sub 10 is the worst overall. Worst. And that's kind of interesting because we like to think that every time we increase the number of rectangles it's going to get better, but that's not actually a fair statement. The statement is that if you increase the number of rectangles infinitely, you're going to get a better estimate. So not necessarily every time you go from 2 to 3 to 4 to 5 rectangles are you going to get improvement. But in general, as you get more and more rectangles, you get better and better estimates. And what's happening here, am I getting ahead of myself a little bit? Let me see what we were asked. Can you explain why L10 is a poorer approximation? Okay, so I think I can. And the answer is that every time we do an even number of intervals, we're going to hit this discontinuity, which means we're going to miss what's going on up above. and just kind of skip right over a whole lot of that. So when we have an even number, we're going to get a lot closer to catching some of that area up above. So that's what I think is happening. And I do think for part E that a similar pattern will hold. And in general, as we get bigger, we're going to continue to see that those evens do a little bit worse than the, I'm sorry, am I saying it backwards? Yeah, the evens, oh, so I changed my answer. Oh my goodness, read my own question carefully. Similar pattern, maybe it's similar, but it's not exactly the same. I think that we will see 14, 15, 16. I think that 14 and 16 will not be as good as 15. So kind of the same pattern, kind of a different one. As n goes to infinity, I think we should still see that as those rectangles get skinnier, skinnier, and skinnier, we get less and less error because of that silly discontinuity in the middle. Okay, thanks for watching.